I'm going to explain branch and bound algorithm. Before we move into the algorithm, let's get a brief background. In machine learning, curse of dimensionality refers to the problems that arise when working with high dimensional data. The dimensionality refers to number of attributes or features in your dataset. If there are a large number of attributes, then it refers to high dimensional data. But the difficulties arise when training machine learning models due to high dimensional data. So this graph shows the curve of dimensionality curve. The x-axis represent dimensionality or the number of features, where the y-axis shows the classifier performance. Initially the performance is increased, but then if you keep on increasing the number of features, the performance decrease. So up to a certain number of features, the accuracy of the classifier can be increased, but then there is a threshold after which the performance starts to decrease. Because of this, the optimal set of features has to be found to mitigate curse of dimensionality. This challenge has motivated to find many different feature selection algorithms over the past decades. Branch and bound is one of such algorithm developed by Narendra and Fukunaga in 1977 for feature selection. So basically branch and bound algorithm is used for minimization problems. This is a brief introduction about the algorithm. It basically follows a tree structure to select the best set of features, and it assumes that the feature selection criterion is monotonic. It can find the best set of features without having to calculate all possible subsets. Therefore, it doesn't involve exhaustive search. So there are two main steps in the branch and bound algorithm as branching and bounding. Branching basically involves constructing the tree. When you are constructing the tree, for each tree level, a limited number of subtrees has to be generated by deleting one feature from the set of features in the parent node. And the bounding is basically the process of finding the optimal feature set by traversing the constructed tree. So let's look at an example. Suppose you have a dataset which has 6 features as f1, f2 and likewise up to f6. So you need to find the best 2 features from these 6 features. We have to start by identify the properties of the tree. The first property is the number of levels. Since we have to select 2 features from the 6 features, 6 minus 2, the number of levels that in the tree we are going to construct is 4. And then the number of leaf nodes are 62, which is equal to 50. Let's assume that the criterion function value is jx. So we have to start constructing the tree by branching. The root node has to have all the features. This is my root node. I have added all the features f1, f2, f3, f4, f5 and f6. Then the intermediate channels have to be created by reducing one feature from the parent node. Here I am removing the f1 feature and creating this node. Then I am going to remove f2 and create this node. And then here I remove f3 and create this node. As you can see here, I removed these features in ascending order. That was done to avoid the chances of subsets getting duplicated. So this is my level 1. Also, you may have noticed that I did not remove F4, F5 and F6 features to create 3 other child nodes initially. Because if I do so in the beginning, I will not have features to remove in the next level. So you have to follow the process until leaf nodes are reached. This is the level 1 I showed in the previous slide. Then again from those child nodes I have to remove one feature create these child nodes. So this level 2 is created. For example, here this is the child node I created earlier with the features F2, F3, F4, F5 and F6. So I removed F2 and created this node, and I removed F3 and created this node, and I removed F4 and created this one. So likewise I removed one feature and created this. That is level 2. Level 2 has nodes with 4 features. Then again, I have to remove one feature and create the other child nodes. From this node, I have removed F3 and created this node. Again, I have removed F4 and created this node, and again, I have removed F5 and created this one. Likewise, I have to follow the process. As I explained earlier, I have removed the features in ascending order, that is level 3. In level 4, I am left with subsets of 2 features. In the last level, I am left with 15 leaf nodes which have 2 features. Then we have to set the criterion function jx for the subsets that we created. Just to show you, I have assumed some values for this criterion function here. For example, in this node, the criterion function value I have set to 20. The immediate child node criterion function values I set as 8, 18 and 15. And likewise, then I have to start pruning. Pruning is basically the process of removing the unnecessary leaf nodes. We have to start with the rightmost node. We have to set the rightmost leaf node value as bound. Our rightmost leaf node value is 9. Therefore, our current bound value is 9. Then I have to backtrack along the tree if the current node value is greater than or equal to the bound value. If I go back, the boundary is 9. Then if I go back to here and go to this node 18, which is greater than 9, so I continue and come to this node, come to this 16. Again 16 is greater than 9, so I am going to continue, uh, and 10 is greater than 9, so I am going to continue, and I come to this leaf which has a value of 7. I need to update the bound value only if the leaf node value is greater than the bound value. Here 7 is not greater than the bound value, which is 9. So I'm not going to update the bound value. My bound value remains as 9. Then again I'm going to backtrack and come through this node and continue. When I come to this leaf node which has a value of 10, uh, so 10 is greater than 9, therefore I need to update my bound value. So the current value is 10 and my bound value is also 10. So I can discard or prune branches if the current node value is less than the bound value. For example, now my bound value is 10. Then if I again go through this node, this has a value of 9, which is less than 10. Therefore, I do not need to continue through this node. So I can remove it. If I again go back and come to this node, this has again value of 8, which is less than the bound value 10. So I do not have to continue that branch. Since I am not left with any other branches to proceed, my maximum bound value is equal to 10. The subset with the criterion value 10 has the features f1 and f4. Therefore, the optimal feature subset is f1 and f4. I'm going to demonstrate how this algorithm works in RStudio. I have gone to the UCR repository website and I will select a dataset to demonstrate how the branch and bound algorithm works. I'm going to select this absenteeism at work dataset. You can see basic details about the dataset here. It has 740 instances and 19 features. I will download the dataset. This Word document has some uh, basic information about the dataset. As we saw earlier, it has altogether 21 categories. This has information about those 21 categories or attributes. The first attribute is about the individual identification. The second one is the reason for absence. The third attribute is the month of absence. The fourth one is the day of the week. Uh, Likewise, we have 21 attributes. The last one is absenteeism time in hours. I'm going to show how this algorithm works using Leaps library. First, I will import the library. This absenteeism at work is going to be my dataset. So then I have to import the dataset to RStudio. This is the imported data with 21 attributes. I can view the dataset from here as well. Now I'm going to define the x and y variables. I'm going to use the model.matrix. I have to select my response variable. The response variable has to be the absenteeism time in hours. I have set the response variable. The minus one is to uh, take the intercept out. I am going to set the data set as the data that has to be used here. Uh, Now I have defined x and I need to define y. This is the data set and then uh, the response variable. Now I have defined the variables x and y. We need to fit the x and y variables using leaps function. I'm going to select the best the best model. Now we have run the model. Let's see what the best models are. Here are the models. The columns represent the attributes. The ones with true are the features that it suggests. If you want the best model with only one feature, this is the one uh, which only has the second attribute. This is the reason for absence. It does not have the other attributes. The second model that it suggests has two attributes. The reason for absence and this 9, 10, 11, 12. 12th attribute. Since it does not have enough space to display, uh, I have altogether 21 attributes and I removed the response variable. So I have 21 attributes shown here. The second model has only two features, the second one and the 12th attribute. The 12th attribute is the disciplinary failure. So the third model has three features. The second one, the 12th one, and 14th one. Likewise, it suggests several models with the number of features that we want. For example, if you want 5 features, then we have to go for this one. The ones which have the value true are the features that we have to select. It has suggested 20 models, and these are the label names set for the attributes 1, 2, 3, 4, 5, 6. Likewise, A, B, C, D, E, F, G, H, I, J, and K. Those are the label names set for the attributes. So we need the best model. For that, I'm going to use mallocp function to find the best model. To find the best model, we have to select the model with the least mallocp value. The least value is 5.952688. Let's see which model has that value. This is the one, the 10 11th model. So the best model would be the model with these 11 features. First feature, second feature, fourth feature, 5, 6, 7th feature, ninth feature, 10, 11, 12, 14th, 16, and 17. And likewise, this is the best subset that it suggests. The best subset has 11 attributes out of the 21 attributes.